I did a recent video on Hart's retro binary watch, which is a kit that is targeted for one of the upcoming vintage computer festivals. And I decided to try making a case for it of some sort. The watch was not designed to have a case. It doesn't really have a lip around the edge or anything where you could attach it to a case easily. It's really just a standalone thing, but just for fun, I decided to try my hand at making a case. Initially, I decided trying to make it to fit a watch band would be pretty awkward, and the watch is quite deep and it wouldn't go under sleeves very well and so on. So I targeted my case design to more of a pocket watch type configuration, or maybe one that you could wear on a lanyard around the neck, that type of situation. Once again, I decided to use Autodesk's Tinkercad web application to design the 3D files. And here I'm starting out with the body of the case and just starting with a cylindrical slug, which I'm then going to whittle away at with negative space characteristics and little attachments. Here I've added the negative space to make it into a tubular section. And here's the same thing viewed from a different angle. At this point, there's only 20 flat surfaces on the polygon that's used to create the curved shape, so later on I changed that to 50 sides so it would be rounder. Because there's no place for a lip that will encircle the front of the watch to keep it from popping out the front of the tubular case, there's really only two places on the circuit board that have any place to get a purchase on the front side, and those are on either side of the two switches. So on the left side of the set switch and the right side of the display switch. So I've just made these two little blocks, sort of nubs that are going to fit on the inside. And because Tinkercad doesn't have an absolute coordinate system like a good CAD program should, but it's only got a relative coordinate system, I had to start out by docking these with the outside periphery of the case body and then offsetting them from there to get them in the desired position. Here I've increased the number of sides on the polygon to 50 so it looks closer to the way it will be in reality. And then here's a photo of after I'd grouped the cylinder and the nubs or the tabs so they are one object. The tabs don't go all the way back. They only go as far as the front of the circuit board where it needs to be so that the LEDs are flush with the front of the tubular section. And I have to orient it this way so that when it gets printed, the tabs are on the side that's going to be on the printing surface, so I don't have to have a support structure for them. Otherwise, they'd be an overhanging object during printing. So the back of the case has somewhere to dock into. I've created a negative space disc here, depth 2 millimeters, and here I've incorporated it into the back side of the cylinder, so it has that little recess in there. And here's a view from a different angle so you can see how it looks. This would be from the back of the case looking forward. The back of the case in its simplest form will just be a disc that fits into that recessed area in the body of the case. And so I've started out with a disc of 2 millimeters thickness and the appropriate diameter. The watch circuit board in the case can't go forward because of the two tabs already shown. To keep it going backwards too much, there are going to be two little ribs that are shown here in green, and those will rest against the back of the circuit board in pretty much the only places that are clear that don't have some reverse side component or row of solder joints that are going to bump up from the board and be of uncertain depth depending how different people assemble the kit, how close they trim the leads and so on. So these things are going to be positioned to fit into the known clear areas. And here I've grouped all those components into a single piece so they're the same color. Because this back plate is friction fit into the recess on the body of the case, and there's nothing to grab it with to pull it off if you need to access the watch, I decided to put two little slots on there, sized to fit a small screwdriver so you can stick it in there and kind of pry the back up. Well, so far the case is just going to be a pocketable watch with the case providing protection to the sides and rear of the circuit board, and because of the recessed nature of the watch in the case, all the little delicate components on it are also fairly well protected. But in order to make the watch carryable without using a normal wristband, which I've already ruled out, I've decided to make an alternate back plate for the case that is a little thicker and projects beyond the recess in the body of the case so that it can have a small tab on it, and the tab is sized and shaped to accept either a pocket watch chain or one of the many common lanyards of the kind that are used for small digital cameras and things, so you can hang them around your neck. So that's what this picture is here. This is the tab that has the hole in it for the lanyard, and I'm going to attach that in the next step. So here's the tab attached or sort of merged in with the edge of a new disc, also 2 millimeters in thickness, but of a diameter that's equal to the outer diameter of the case body. And therefore, once I merge these or group them, then they'll be one object. So here's after the tab is merged and grouped with the plate, and now I have to center align and group the normal back plate with its two projecting ridges and this extra plate with the lanyard tab on it. And as with the regular back plate, I've added two small slots here so a screwdriver can be used to pry this out of the case. With the STL files created for each of the two backs and for the body of the case, I dragged them all into my Prusa slicer, and they have been rendered here, and I've generated G-code for going to my Prusa printer. Here are a few pictures taken during the process of printing the three parts. Here's the case body viewed from the rear. You can see the recess for the back plate and the rear end of the two front tabs. And here's a view from the front showing the tabs projecting into the cylinder. Here are the two different versions of the back plate viewed from the rear, and here are the same two viewed from the front side. Okay, for test fitting, here is the body of the case looking at it from the rear, and here is with the watch circuit board pushed in against the two tabs so that the tabs fit on either side of the two switches, and those are again the only places where they really can go. And here's placing the back plate into the case. You can see in this first photo that the two ridges will align with the relatively open areas on the circuit board above and below the battery holder. And then here are some views of how it all fits in there looking at it from the front. Here's using a screwdriver into the small slots to pry the back off. It fits in there firmly enough to not fall out, but just a little effort with the screwdriver and it pops out easily enough. These last two photos show the back with the tab for the lanyard, both rear views and front views.